11.4, we're going to start moving away from having everything centered at 0, 0. In 11.1, 2, and 3, we had a vertex of 0, 0. We had centers at 0 and 0 for our hyperbolas and ellipses, but we're going to move away from that into problems like number A here. By the way, how could you tell what the shape of this is just by looking at it? Hyperbola, ellipse, or yeah, plus sign. How come it's not a parabola versus an ellipse? Yes, well done, because you got two squared terms. Now, you might want to rewrite this as x minus 2 squared over what? 4 squared, and then y minus 3 squared over 3 squared equals 1. So kind of a interesting coincidence there. Where does that put your center? Well, your center is going to be where the squared terms are equal to 0. So the center in this one is where? 2 and 3. So conveniently, that's right here. Now in the x direction, you need to find your vertices of the ellipse. So that's going to be moving a distance of 4 to the right and 4 to the left to find your vertices that direction. How about in the y direction? How far do I have to move? Up 3 and down 3. And if you start out at 2 and 3 and move in those directions, you can find the coordinates of those points pretty easily, so I'm not going to worry about that. There is one more thing that you're asked to find here, and that would be the foci for the ellipse. Now for the foci, now there's that formula with the c squared and the b squared and the a squared. But what goes here, a plus or a minus? Little hesitation on that one. Let's put in the minus. Now what should happen is we should get foci that are inside the ellipse. Now if you try and graph it on the minor axis, you might run outside the ellipse. If you have a plus here instead of the minus, again you're going to get foci outside the ellipse. It should be on your major axis, a distance of c away from the center. So that's going to be 4 squared minus 2 squared, or 12. Oh, I'm sorry, 3. My bad. Thank you. 3 squared minus 2 squared. How about 4 squared minus 3 squared? There we go. Man, rough start. 4 squared minus 3 squared, so 16 minus 9 is going to be 7, so square root of 7. Square root of 7, close to 2.6, I'm guessing. I don't know. Someone want to calculate that for me? So
2.645.
2.645. All right. So 1, 2, and change. So about here. 1, 2, and change. About here. Except what are the coordinates? Now, a lot of times on an exam, I'll ask for the exact coordinates of the center and the foci, those kind of things. Let's see. Well, we started out from the center, which was at 2 and 3. Which coordinate am I adjusting when I move to the left? The x coordinate. So call it F1. F1 is going to be 2 minus the square root of 7 and 3. What about F2? How am I going to find that coordinate? Yeah, the y coordinate doesn't change, so I'll leave that there as a 3, but we're adding square root of 7 to move to the right by that distance, so there's your foci. Great. Now let's flip things over to the next page, because I'm going to let you do some of these problems, B, C. So that's going to bring us to problem D. Does that equation look like an ellipse? I mean, that's what I've got drawn down there, but does that really look like much of an ellipse? It doesn't. It really doesn't. Now, if you plug that in on Desmos, it should graph to be an ellipse. So let's just open up that link there. I think I've actually already got it open. So, yeah, right down here. Okay, yeah, it's looking like an ellipse. Yeah, it looks actually different than the one I have graphed there. We'll have to find out which one's right in just a minute. But how could you tell just based on the equation that that's actually an ellipse and not a hyperbola or a parabola? How come it's not a parabola? That's the easy part. Why is this not a parabola? Yeah, you have two squared terms, all right? So it's either going to be ellipse, a circle, or a hyperbola. Now, the next clue. These coefficients are both positive. So it's either an ellipse or a circle. The final thing you can check is if these coefficients are the same, then you're going to end up with a circle. If they're not, then it's going to be an ellipse. So let's work with that. Now I got to do a little bit of review for you guys. The reason I don't do review at the beginning of the semester is because by the time you need it, you've already forgotten it. So this is some review of completing the square. Some of you who had me for Math 1150 might remember this kind of a problem. I would set something up like x squared minus 12x plus something equals something squared. And I'd ask you to figure out what number you're going to put in here, and then this should factor as a perfect square trinomial as x and then something squared. So what's the trick in figuring out how to factor these kinds of things? Well, there's two steps. Step one, you're going to take whatever's here and multiply it by 1/2. Now I'm not trying to motivate this a little bit for you. I'm just trying to show you how it works. So multiply middle coefficient by 1/2. And that's going to look like this. 1/2 times negative 12 is negative 6. Okay, great. Then what? You're going to square the result from 1. So you're going to square the result from the first step. So I'm going to take that negative 6 and square it. And what do I get when I square negative 6?
36.
Positive 36. Great. Now that 36 and that negative 6 are going to help me factor this thing right here. So the first part that I need to finish up here, right there, that 36 goes in on the first part. So 36 there. For the second part, I'm again going to use part of my work here. It's going to be x minus 6. And there you go. If you're wondering a little bit why this works and how this works, what you could do for yourself would be take a polynomial like x plus 3 and square it, and realize that you get x squared plus 3x again. So plus 3x again plus 9. And where does the 9 come from? It comes from 3 squared. And 3 is half of this number. So if I were to give you a problem like this and said, all right, figure out what to square to make this a perfect square trinomial, you realize, oh, well, the number that I square to get this is half of this number, which is exactly what we're doing here. So that's the process of completing the square. So kind of a little review for you on that. Let's turn our attention back to problem D, which is going to ask us to do that and a lot more, to be honest. All right, so example D. We've got 4x squared plus 25y squared minus 16x plus 250y plus 541 equals 0. Whew. All right, well, the first thing I want to do is I want to rearrange my terms to get some of the like things together. And they're sort of like. I want to put the x's together. And I want to put the y's together. And then this term, I'm just going to get rid of it. I'm going to move it to the other side. So what's that going to look like? Well, that's going to be 4x squared minus 16x plus 25y squared plus 250y equals negative 541. Nothing magic yet. All right, well, let's keep going then. I need to complete the square. If you look at our example here, there's something important about this example, and that is the coefficient of my x squared term. What's that coefficient? 1. It has to be a 1 in order to complete the square. All right. Unfortunately, I don't have a 1 in front of my x squared, nor do I have a 1 in front of my y squared. And this is probably the place where it's easiest to make a mistake. A lot of people want to factor out the greatest common factor between these two. That's not what you want to do. Instead, what you want to do is factor out just the 4. So if I factor out just the 4, it's going to leave behind x squared minus 4x. And leave yourself a little space there. X squared minus 4x. We're going to fill in that with the right number to help ourselves out. Let's do likewise over here. 25 times y squared plus what? Elizabeth? If I factor out the 25 from both of these terms, what's left?
10y.
Yeah, plus 10y plus, call it something, equals negative 541. So all I did is I factored out those terms. What I got to do next is I got to fill in these numbers to make them perfect squares. That was why we did this little bit of work here with completing the squares. Overall, our goal is to try and make this look like a nice completed the square ellipse like we had to start out with, something like that. So I need a perfect square here. Let's work on this first one together. Remember, you're going to take half of the middle coefficient. Half of negative 4 is negative 2. Good. And negative 2 squared is 4. So we're going to have to put a 4 up there. So let's put the negative 2 here. Now, don't put anything on the right-hand side just yet. Let's try the same thing with the middle one, or the y term. Half of something. Half of 10. Good. Half of 10 is 5. And 5 squared, of course, is 25. I'll put a 25 in here. But here's the tricky question. What am I going to put on the right-hand side to keep this in balance? For instance, I put a 4 here, and then I put a 25 here. What am I going to do over to the right-hand side to make this balance out? I heard Pfeiffer say 4 times 4 is 16. You don't want to put just a 4, because really by putting the 4 here, you've added 16 to the right-hand side, because that 4 has to distribute itself. So do plus 16 on the right-hand side. And plus what else? Nikki, you had your hand raised. Maybe you can do this one. Then you can take out a calculator. What's that?
You add 25 squared.
Yeah, 25 squared, which would be 625. Perfect. Thank you, sir. So 625. Great. So on the right-hand side, we end up with 100. Just adding those things together. On the left-hand side, I've made great strides. On the left-hand side, I can rewrite that as something squared. I can write that as 4 times x. You tell me. What am I going to fill that in with?
That's true.
Minus 2. Thanks, Syed. Plus 25 times something squared. Someone else for that something. Nora, what would I square to get that term? Yeah, y plus 5. Hopefully not just to 5, right? It's y plus 5. Thank you. All right, that's looking a lot nicer. Getting a lot closer to where we need to be. What are we going to do to finish this one up? To get it in that nice form.
You divide the 4 and 25 out of those, right?
Divided by 100.
Yeah, we'll divide everything by 100. Yeah. So 4 times x minus 2 squared plus 25 times y plus 5 squared equals 100. So we'll divide everything through by that 100. It's in my office. I'll have to get it later. Four cancels there. It's going to leave me with a 25. 25 cancels here. It's going to leave me with a 4. And I got a 1 here. Last but not least, x minus 2 squared over 5 squared plus y plus 5 squared over 2 squared equals 1. Okay. Looking good. Ellie.
So, is x minus 2 squared divided by 25 plus y plus 5 squared divided by 4 equal 1, like the final form, like the most reduced form possible, or is it the second one that's
Well,
the most reduced form possible?
What's the advantage in going from this down one more step?
We have the vertices.
Yeah, I mean, once you have the center, what's the center on this one, Ellie?
2, negative 5.
2, negative 5. All right, so looking good there. And once you have the center, then it's easy to get the vertices. So this graph does look right. Didn't seem to match the one I had up on Desmos just a minute ago, but I'll take a closer look at that. And now, because you have it in this special form, you can find these vertices by moving 5 to the right, 5 to the left, up 2, and down 2, and you've got your vertices. So to me, I think it's advantageous to rewrite them using the square root of the number. It's up to you. I mean, maybe you can just look at that and go, okay, 5 to the right, 5 to the left. And if that's you, that's fine. I don't think I'm going to mark it wrong if you left it here. All right. And certainly, even if I was at my grouchiest, that'd be minus a point at most. I mean, even on a really bad day, that's not a big thing. The big thing is to get down to here.
So you want the 5
I would. This is what you'll see from me in the answer key. All right. Now, if you leave it like that, you know, it's not my biggest of concerns. All right. Overall, expect 1 on completing the square. Are you comfortable with all those steps in here? I guess the biggest thing that you got to remember, and I tried to color code these things as best I could, is that when you complete the square, you've got to put not just this number, but that number times this number on the right-hand side. And then 25 times 25, etc. So, all right. Looks good on that one. Let's see. Let me figure out where else we're going to go here next. Well, actually, let's take a quick look at F. Yeah, I don't think I asked you to solve F. So, and let me pop up F this way. says complete the square to determine whether the graph of the equation is an ellipse, a parabola, hyperbola, or degenerate conic, or results in no solution. So let's see what happens on this one. I'm just going to copy this down. So example F. We've got x squared plus 16 equals 4 times y squared plus 2x. I guess for me, what I would start out with is distributing the 4y squared plus 8x. And then let me maybe move the x squared to the other side. So, well, let's see here. Do I want to move everything to the left-hand side? I guess I'll move everything to the left-hand side. X squared minus 8x plus 16 minus 4y squared equals 0. So I moved everything to the left-hand side. Notice I bundled everything up together here. Is there anything interesting about this trinomial? How does it factor?
It factors, I would say -4 and -4.
Yeah, -4 and -4.
Or x minus 4 squared.
Ah, well done. X minus 4 squared minus 4y squared equals 0. Now it's interesting that we've got two squared terms like this. I mean, initially up here, you wouldn't be wrong in your thinking if you're expecting a hyperbola because you have two squared terms that are opposite in sign. We've got a 0 here. Let me move the y squared to the other side. X minus 4 squared equals 4y squared. I could take the square root on both sides. Now on the right-hand side, square root of 4 is 2. Square root of y squared is going to be y. On the left-hand side, I want to put the plus and minus. Now I'm not going to put the plus and minus on both sides because it kind of tends to cancel itself out. But you get plus or minus x minus 4. Our positive case is x minus 4 equals 2y. And our negative case is negative of x minus 4 equals 2y. Negative x plus 4 equals 2y. Or negative x plus 4 over 2 equals y. What do these last two equations graph to? What would I get if I graphed this one? What would it look like? Can you tell me what either of these graphs would look like? Nothing? Let's see, do I have that one there? Bam. Just two lines, right? That's all there is. So this is what's called a degenerate conic. So, you know, dropped out of school, you know, didn't do much with their life, etc. It's a degenerate conic. All right, so that can happen. It's not the typical problem that I'm going to ask, but you might see one like that in your homework. If you do, you won't be surprised. Let's see. H. Yeah, let's take a look at example H. This is an example of the kind of thing you're going to see on WebAssign. In particular.
Wanted us to skip I.
Oh, that's I. Yeah. All right. All right. But let me just kind of make a remark here about what you might see on WebAssign. This is kind of generic stuff that'll fit any conic. A center, a focus, etc. Vertex, vertex. All right. So you're not always going to have two vertices if you're dealing with a parabola. So some of these might be, you know, not applicable. But I think you're going to get this kind of stuff because they're not tipping their hat as to what kind of conic you're dealing with. But maybe you can tell me just by looking at this what kind of conic you're dealing with for problem number I. What one does it have to be? Zaid, any suggestions? What would this be?
What was the question?
Is this going to be a parabola, hyperbola, ellipse? Parabola, good. Why? Why do you say parabola? He's right. There's only one squared term. Now, if you wanted to play with this a little bit, you could. I'm going to move the 12y to the right-hand side, and that's going to leave me with x squared plus 2x plus 1 equals negative 12y.
X plus 1.
Oh, yeah, this part right here, Antonio, this is the second time in a row. Well done, sir. That part right there is really x plus 1 squared. So x plus 1 squared equals negative 12y. That's of the correct form for us to kind of figure out what else we might need from this in terms of, its graph. Now, your parabolas are going to have two general forms. And remind you, for parabolas, it's either going to be x minus h squared equals 4 times p times y, or actually not quite 4 times p times y. 4 times p times y minus k. Or y minus k squared equals 4 times p times x minus h. Either one of these is going to have a vertex at h and k. Vertex at h and k. What can you tell me about the first one? Which way does it open? Up and down or left and right?
Left and right.
This one's going to be a parabola.
Oh.
So let me clean this up a little bit. Four and P. It's either going to open up or down because it's a parabola and x squared. A parabola and y squared opens left or right. It's kind of depend on the sign of P here. But once you determine P, you're going to move a distance of P away from the vertex to try and find your focus, and P away from the vertex in the other direction to find your directrix. So keep that in mind as you're working with example I. All right, our last one here. I think it's our last one, example H. We've got a vertex for our parabola at negative 5 and 5, and a directrix of y equal 2. So let's draw this. It helps to have a good picture. This one doesn't happen to have a drawing with it, so let me supply one. Let's see. I'm going to move down and give myself a generous amount of room. Okay, and let's draw a couple in this way as well. 1, 2, 3, 4. So our vertex is at negative 5 and 5, so it's going to be up here. What's the line y equal 2 going to look like? Is it going to be vertical or horizontal?
Horizontal.
Yeah, horizontal. Nice. So y equals 2. Let's put that in here. And what I want you to do is I want you to try and determine which way this has to open. Because which way this has to open is going to determine if you're going to use this equation, x minus h squared equals 4 times p times x, times y minus k, or y minus k squared equals 4p times x minus h. So you have to decide which one is correct based on which way this is going to open. Is it clear to everyone which way is open? At least, what do you think? Which way does it have to open? Yeah, it has to open up. If it opens any other way, if it opens to the right or to the left or to down, it's going to cross its directrix. It can't cross its directrix. So it has to open up. All right, so that's going to mean this one opens up. That's going to mean that P has what sign?
Positive.
P has to be positive to open up. And we know something else here that's going to help us out in determining our equation. What else do we know that we've already been given? We're going to need. It's already been given. Jaya, what do you got? What else do we know from this equation that we've already been given? All right, H and K. H and K because we've got our vertex, right? So there's your H, there's your K. What's the only thing left we need to determine then? P. So P is going to be 3. P is this distance. P equals 3. So we can fill this all in then. Find our equation. X minus, x minus negative 5 squared equals 4 times 3 times y minus 5. Overall, x plus 5 squared equals 12 times y minus 5. From there, if you wanted to or needed to, you could solve for y. I mean, this is fine as far as I'm concerned, but you could solve for y if you divide both sides by 12. Squared equals y minus 5, and then add 5 to both sides. So overall, you'd be left with 1/12 times x plus 5 squared plus 5 equals y. That's the form you'd have to put it in if you were going to graph it. Frankly, I'd be pretty happy if you got this far. And if you do this, you might as well go all the way and finish it up like this. So either of these two forms are looking good. Whew. All right. How are we looking on that one? Cool. All right. Let's stop it here.